Hello everyone, I'm Professor Diwa. In this video, I'll be going over solving systems of linear equations in two variables. Our objectives are to determine whether an ordered pair is a solution of a system of linear equations, solve a system of two equations by graphing, solve a system using substitution, solve a system using elimination. Alright, so let's get started. First, we have the definition for a system of equations. It states here that a system of equations is a set of two or more equations and two or more variables for which a common solution is sought. In the next set of examples, we're going to solve a system of two equations with two variables using different methods. For example number 1, solve by graphing. First, we have the equation 2x plus y equals 1, and the second equation, x plus y equals -2. To graph these equations, we're going to first put them in slope-intercept form. Starting with the first equation, 2x plus y equals 1, I'm going to subtract 2x from both sides of the equation. After doing the subtraction, we get y equals -2x plus 1. For the second equation, x plus y equals -2, we go ahead and subtract x from both sides. We get y equals -x minus 2. Now that both equations are in slope-intercept form, I'm going to graph y equals -2x plus 1. Starting with the y-intercept, I'm going to plot my first point at 0, 1. From here, I'm going to use my slope of -2 to go down 2 spaces and over 1 to our second point. Next, I'm going to use the slope a few more times to get a few more points on the graph. So I'm going to go down 2 and over 1, and down 2 and over 1 more. From here, we could go and draw a line through our points. Next, we graph our second line, y equals -x minus 2. We start by plotting a point at the y-intercept of 0, -2, and then we use our slope of -1 to go down 1 and over 1, so we have our second point. And then we go down 1 and over 1, we have a third point, down 1 and over 1 to our last point. Now we go ahead and draw a straight line through our points. The solution to this system of equations is where the two graphs intersect. You can see that the two graphs intersect at this point here, which is 3, -5. So our final answer is written as an ordered pair, parentheses, 3, -5, close parentheses. Next, we have a practice problem for you to try. Solve by graphing. We have the equation x minus y equals 1, and the second equation, x plus y equals 3. Alright, so go ahead and pause the video, graph this problem, and then check back with the video to see the solution. Okay, so let's start by putting the first equation, x minus y equals 1, in slope-intercept form. We start by subtracting x from both sides of the equation. After doing the subtraction, we get -y equals -x plus 1. Next, we need to get rid of the negative sign in front of the y. We just divide both sides of the equation by -1. We get -y divided by -1 equals -x divided by -1 plus 1 divided by -1. Simplifying the left-hand side, we have -y divided by -1 is just y, and on the right-hand side, we have -x divided by -1 is positive x, 1 divided by -1 is -1. So our equation in slope-intercept form is y equals x minus 1. Next, we write the second equation in slope-intercept form by subtracting x from both sides of the equation. We get y equals -x plus 3. Next, I'll start by graphing y equals x minus 1. We start by plotting a point at the y-intercept of 0, -1. From here, we use the slope to get our second point, and you could use the slope again to get a few more points. And then we draw our line. Next, we graph our second equation, y equals -x plus 3. So I started by plotting my first point at the y-intercept of 0, 3, and then I used the slope of -1 to get a few more points and graph my line. Here we could see the intersection of this graph takes place at 2, 1, So our final answer, written as an ordered pair, is parentheses 2, 1, close parentheses. For example number 2, determine whether the given ordered pairs are solutions of the system of equations. We're given the system 2x plus 3y equals 9 and negative 5x minus 3y equals 0. For part A, we need to determine if the ordered pair 6, negative 1 is a solution to the system. What we need to do here is take the x and y value of the ordered pair and plug it into the x and y variable into both equations in our system. Starting with the first equation, 2x plus 3y equals 9, we substitute in 6 for x and negative 1 for y. We get 2 times 6 plus 3 times negative 1 equals 9. Simplifying this, we get 12 minus 3 equals 9, which simplifies to 9 equals 9. Since 9 equals 9 is a true statement, this means our point is a potential solution to the system. Next, we check the point in the second equation, negative 5x minus 3y equals 0. We substitute in 6 in for x and negative 1 in for y. We get negative 5 times 6 minus 3 times negative 1 equals 0. Simplifying this, we get negative 30 plus 3 equals 0, which gives us negative 27 equals 0. This is false. Negative 27 does not equal 0. This means that the ordered pair 6, negative 1 is not a solution to the system. Moving on to part B, we have the ordered pair negative 3, 5, and we just follow the same steps. So I'm going to substitute in negative 3 in for x and 5 for y into our first equation. We get 2 times negative 3 plus 3 times 5 equals 9. Simplifying this, we get negative 6 plus 15 equals 9. Simplifying further, we get 9 equals 9. This is true, so we move on to the second equation. We plug in negative 3 in for x and 5 in for y. We get negative 5 times negative 3 minus 3 times 5 equals 0. Simplifying this, we get 15 minus 15 equals 0. Simplifying further, we get 0 equals 0, which is true. This means that the ordered pair negative 3, 5 is a solution to the system. Next, we're going to talk about the 3 different situations that can occur when you're solving systems graphically. Here it states, when we graph a system of 2 linear equations in 2 variables, one of the following 3 outcomes will occur. Number 1, the lines have a point in common, and that point is the only solution of the system. Any system that has at least one solution is said to be consistent and independent. If we take a look at the first diagram below on the left, you can see we have a graph that describes this situation. We have 2 lines that intersect at a single point, which means that this system is consistent. We also have 2 distinct lines, which means that this system is independent. Moving on to number 2, it states, the lines are parallel with no point in common, and the system has no solution. This type of system is called inconsistent and independent. If we take a look at the middle diagram below, this graph here describes this situation. We have 2 parallel lines that don't intersect, so that means there's no solution. That makes this system inconsistent. Also, we have 2 distinct lines, which means that this system is independent. Moving on to number 3, the lines coincide sharing the same graph. Because every solution of one equation is a solution of the other, the system has an infinite number of solutions. Since it has at least one solution, this type of system is also consistent and dependent. If we take a look at the diagram below on the right, you can see we have a graph that describes this situation. We have 2 lines graphed directly right on top of each other, so it looks like a single line. Because the 2 lines intersect each other at every single point, the system is consistent. However, because we don't have 2 distinct lines, we classify the system as dependent. In example number 3, classify each system as consistent or inconsistent If the system is consistent, state whether the equations are dependent or independent. For part A, we have the system x plus y equals 1 and x plus y equals -1. We start by putting both equations in slope-intercept form. Starting with the first equation, x plus y equals 1, we subtract x from both sides of the equation. The result is y equals -x plus 1. The slope for this equation is -1, and the y-intercept is 0, 1. Next, we put the second equation in slope-intercept form. We start by subtracting x from both sides of the equation. The result is y equals -x minus 1. The slope for this equation is -1, and the y-intercept is 0, -1. We could see that the slopes for both equations are the same, and the y-intercepts are different. This means that we have two parallel lines which don't intersect. This means that this system is inconsistent, and because we have two distinct lines, we also classify the system as independent. Moving on to part B, we have the equation x plus 2y equals 4 and 2x plus 4y equals 8. Again, we need to start by putting both equations in slope-intercept form. So I'm going to start with the first equation, x plus 2y equals 4, and subtract x from both sides. The result is 2y equals -x plus 4. From here, we get rid of the 2 in front of the y by dividing both sides by 2. We get 2y divided by 2 equals -x divided by 2 plus 4 divided by 2. Simplifying the left-hand side, 2y divided by 2 is y. Simplifying the right-hand side, -x divided by 2 can be rewritten as -1/2 x. 4 divided by 2 is 2. So the equation in slope-intercept form is y equals -1/2 x plus 2. The slope is -1/2, and the y-intercept is 0, 2. Next, we put the second equation in slope-intercept form, so I subtracted 2x from both sides. We get 4y equals -2x plus 8. From here, we get rid of the 4 in front of the y by dividing both sides by 4. We get 4y divided by 4 equals -2x divided by 4 plus 8 divided by 4. Simplifying the left-hand side, 4y divided by 4 is y. Simplifying the right-hand side, -2x divided by 4 is -1/2 x. 8 divided by 4 is 2. The equation in slope-intercept form is y equals -1/2 x plus 2. The slope is -1/2, and the y-intercept is 0, 2. We could see here, without having to look at the y-intercept and the slope, that both equations are exactly the same. Because we have the same equation for both lines, their graphs would intersect each other at every single point. This makes the system consistent. However, because we don't have two distinct lines, the system is dependent. Next, we have a practice problem for you to try. Classify each system as consistent or inconsistent. If the system is consistent, state whether the equations are dependent or independent. The system of equations that are given is x plus y equals 4 and x minus y equals 2. So go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Okay, so let's get started by putting the first equation, x plus y equals 4, in slope-intercept form. We start by subtracting x from both sides of the equation. The result is y equals -x plus 4. From here, we could see the slope is -1, and the y-intercept is 0, 4. Next, we put the second equation in slope-intercept form. So we take x minus y equals 2, and we subtract x from both sides of the equation. The result is -y equals -x plus 2. From here, we get rid of the negative sign in front of the y by dividing both sides by -1. We get -y divided by -1 equals -x divided by -1 plus 2 divided by -1. Simplifying the left-hand side, -y divided by -1 is y, and on the right-hand side, Negative x divided by negative 1 is x, and 2 divided by negative 1 is negative 2. So the result is y equals x minus 2. The slope is positive 1. The y-intercept is 0, negative 2. Because the slopes are different, this indicates that we have two lines that will intersect, meaning that there is at least one solution. So this means that our system is consistent. And because we have two different lines, this means that our system is independent. Next, we're going to go over the substitution method. To solve a system using substitution, we do the following steps. Number 1, isolate a variable of one of the equations unless one is already isolated. 2, substitute for that variable in the other equation using parentheses. 3, solve for the remaining variable. 4, substitute the value of the second variable in any of the equations and solve for the first variable. 5, form an ordered pair and check in the original equations. So in the next example, I'm going to show you how we apply the substitution method. In example number 4, solve the system using substitution. For part A, we have the system of equations x plus y equals 4 and x equals y plus 1. The first step is to isolate a variable in one of the equations. However, if we take a look at the second equation, it's already solved for x. So we can move on to step number 2, which is substitute for that variable in the other equation. So we're going to take our equation that solved for x and substitute that into the first equation. So the first equation is x plus y equals 4. We're going to replace the x variable with y plus 1. So we have parentheses, y plus 1, close parentheses, plus y equals 4. Next, we move on to step number 3, which is solve for the remaining variable. In our case, we're going to solve for y by simplifying. Starting with the left-hand side, we combine like terms. We add together the two y's to get 2y. We bring down the plus 1, and on the right-hand side, we bring down the positive 4. So the result is 2y plus 1 equals 4. From here, we subtract 1 from both sides. So on the left-hand side, we have plus 1 minus 1 cancels out, and then we bring down the 2y. On the right-hand side, we have 4 minus 1, which is 3. The result is 2y equals 3. From here, we get rid of the 2 in front of the y by dividing both sides by 2. We have 2y divided by 2 equals 3 divided by 2. Simplifying the left-hand side, 2y divided by 2 is y, and on the right-hand side, we just bring down the 3 over 2. So our result is y equals 3 over 2. Next, we can move on to step number 4, which is substitute the value of the second variable into any of the original equations. I'm going to substitute in my y equals 3 halves into the second equation because it's already solved for x. Replacing y with 3 over 2, we get x is equal to 3 over 2 plus 1, which equals 5 over 2. Now that we have the values for both x and y, our last step is to write our answer as an ordered pair. So I have parentheses 5 over 2, comma 3 over 2, close parentheses. Next, if you want to check your answer, you just take your x and y value of your ordered pair and plug it into the corresponding x and y variable in both of the equations in the system. If you get a true equation for both equations, then that means your ordered pair is a solution to the system. If you end up getting one or both equations as false, then that indicates that you made a mistake somewhere and you need to go back and double check all of your work. Moving on to part B, we have the system of equations negative x over 6 plus y over 2 equals 1/2. The second equation is x over 3 minus y over 6 equals negative 3 over 4. What we need to do first is get rid of all of the fractions for both equations. For the first equation, you can see that we have 6, 2, and another 2 in each of the denominators. The LCD for these numbers is 6. So we multiply all of the terms by 6. we get 6 times negative x over 6 plus 6 times y over 2 equals 6 times 1/2. Simplifying the left-hand side, 6 times negative x over 6 simplifies to negative x. 6 times y over 2 simplifies to 3y. And on the right-hand side, 6 times 1/2 is 3. The result is negative x plus 3y equals 3. Next, we get rid of all the fractions in the second equation. If we take a look at all of the denominators, we have 3, 6, and 4. The LCD between all three numbers would be 12. So we multiply all three terms by 12. We get 12 times x over 3 minus 12 times y over 6 equals 12 times negative 3 over 4. Simplifying the left-hand side, we have 12 times x over 3 would be 4x. 12 times y over 6 would be 2y. And on the right-hand side, 12 times negative 3 over 4 will be minus 9. The result is 4x minus 2y equals negative 9. Now that we got rid of all of the fractions, the next step is solving either one of the equations for either the x or the y variable. I'm going to solve the first equation, negative x plus 3y equals 3, for the x variable. I'm going to start by adding x to both sides and subtracting 3 from both sides. Simplifying the left-hand side, we get minus x and plus x cancels out, and then we bring down the 3y and the minus 3. On the right-hand side, the 3 and the minus 3 cancels out, and we bring down the x. So the result is 3y minus 3 equals x. The next step is substituting our value for x, which is 3y minus 3, into the second equation. So I have 4 times the parentheses, 3y minus 3, close parentheses, minus 2y equals negative 9. Next, we need to solve for y. So the first thing I'm going to do is distribute the 4 inside the parentheses to the 3y and the minus 3. We get 12y minus 12, and then we bring down the minus 2y. On the right-hand side, we bring down the minus 9. So we have 12y minus 12 minus 2y equals negative 9. Next, we combine like terms on the left-hand side. So we have 12y minus 2y is 10y. We bring down the minus 12, and on the right-hand side, we bring down the minus 9. So the result is 10y minus 12 equals negative 9. From here, we get rid of the minus 12 by adding 12 to both sides. Simplifying the left-hand side, minus 12 plus 12 cancels out, and we bring down the 10y. On the right-hand side, minus 9 plus 12 is 3. So the result is 10y equals 3. Next, we get rid of the 10 in front of the y by dividing both sides by 10. I have 10y divided by 10 equals 3 divided by 10. Simplifying the left-hand side, 10y divided by 10 is y, and on the right-hand side, we could bring down the 3 over 10. So the result is y equals 3 over 10. From here, we substitute our value for y, 3 over 10, into the first equation, x equals 3y minus 3. We get x equals 3 times 3 over 10 minus 3. Simplifying this, we get x is equal to 9 over 10 minus 3. Simplifying further, we get that x is equal to negative 21 over 10. Finally, we write our answer as an ordered pair. I have parentheses, negative 21 over 10, comma 3 over 10, close parentheses. Next, we have a practice problem for you to try. Solve the systems using substitution. For part A, we have the system y plus 3x equals 5 and y equals 3x minus 2. For part B, we have the system negative x over 2 plus y over 4 equals 1/2 and x over 2 plus y over 2 equals negative 1 over 8. Alright, so go ahead and pause the video, take your time working out these problems, and then check back with the video to see the solutions. Alright, so let's get started with part A. For part A, the second equation is already solved for y, so we're going to substitute in the value for y, which is 3x minus 2, into the first equation. So we get parentheses 3x minus 2, close parentheses, plus 3x equals 5. The next step is solving for x, so we can get rid of the parentheses and then combine like terms. So we have 3x plus 3x is 6x, and then we bring down the minus 2. On the right hand side, we just bring down the 5. We have 6x minus 2 equals 5. From here, we could go ahead and get rid of the minus 2 by adding 2 to both sides. On the left hand side, we have minus 2 plus 2 cancels out, and we bring down the 6x. On the right hand side, 5 plus 2 is 7. So the result is 6x equals 7. From here, we just divide both sides by 6. So we get 6x divided by 6 equals 7 divided by 6. Simplifying the left-hand side, 6x divided by 6 is x. And on the right-hand side, we just bring down 7 over 6. The result is x equals 7 over 6. From here, we substitute in our value for x into the second equation. So we have y equals 3 times 7 over 6 minus 2. Simplifying, we get y is equal to 7 over 2 minus 2. Simplifying further, we get y is equal to 3 over 2. Next, we write our answer as an ordered pair. We have parentheses, 7 over 6, comma, 3 over 2, close parentheses. Moving on to part B, we get rid of the fractions for the first equation by multiplying by the LCD of 4. So we get 4 times negative x over 2 plus 4 times y over 4 equals 4 times 1/2. Simplifying the left-hand side, 4 times negative x over 2 is negative 2x. 4 times y over 4 is just y. And on the right-hand side, 4 times 1/2 is 2. The result is negative 2x plus y equals 2. Next, we get rid of all the fractions in the second equation by multiplying all of the terms by the LCD of 8. We get 8 times x over 2 plus 8 times y over 2 equals 8 times negative 1 over 8. Simplifying the left-hand side, 8 times x over 2 is 4x. 8 times y over 2 is 4y. And on the right-hand side, 8 times negative 1 over 8 is negative 1. The result is 4x plus 4y equals negative 1. For the next step, I'm going to solve the first equation for y by adding 2x to both sides of the equation. The result is y equals 2x plus 2. Next, I'm going to substitute my value for y, 2x plus 2, into the second equation. We get 4x plus 4 times the parentheses 2x plus 2, close parentheses, equals negative 1. Next, we distribute the 4 inside the parentheses to the 2x and the plus 2. This gives us 8x plus 8, and then we bring down the 4x. On the right-hand side, we bring down the minus 1. The result is 4x plus 8x plus 8 equals negative 1. Simplifying the left-hand side, we can combine like terms. 4x plus 8x is 12x. We bring down the 8, and on the right-hand side, we can bring down the minus 1. The result is 12x plus 8 equals negative 1. From here, we could get rid of the 8 by subtracting 8 from both sides of the equation. On the left-hand side, 8 minus 8 cancels out. We bring down the 12x. On the right-hand side, minus 1 minus 8 is negative 9. The next step is getting rid of the 12. We do this by dividing both sides by 12. So we have 12x divided by 12 equals negative 9 divided by 12. Simplifying the left-hand side, 12x divided by 12 is x, and on the right-hand side, negative 9 divided by 12 is negative 3 over 4. Next, we take our value for x, negative 3 over 4, and we substitute it into the first equation, y equals 2x plus 2. We get y equals 2 times negative 3 over 4 plus 2. Simplifying this, we get y equals negative 3 over 2 plus 2. Simplifying further, we get that y is equal to 1/2. For our final answer, we write it as an ordered pair. I have parentheses, -3/4, comma 1/2, close parentheses. Next, we're going to go over the elimination method. To solve a system using elimination, we do the following steps. Step 1, write both equations in standard form. Step 2, multiply both sides of one or both equations by a constant if necessary, so that the coefficients of one of the variables are opposites. Step 3, add the left sides and the right sides of the resulting equations. One variable should be eliminated in the sum. Step 4, solve for the remaining variable. Step 5, substitute the value of the second variable in any of the equations and solve for the first variable. Step 6, form an ordered pair and check in the original equations. In the next example, I'm going to show you how we apply these steps so that we can solve a system using elimination. For example number 5, solve the systems using elimination. For part A, we have the system x plus y equals 3 and x minus y equals 1. The first step to solve the system using elimination is writing each equation in standard form. You could see that both of these equations are already in standard form, so the next step would be to either multiply one or both equations by a constant so that the coefficients of one of the variables are opposites. If we take a look at both equations, you could see that the y variables are opposites. So we can move on to step number 3, which is just adding together both of these equations. Simplifying the left-hand side, x plus x is 2x, the plus y and the minus y cancel out, and on the right-hand side, 3 plus 1 is 4. The result is 2x equals 4. From here, we can move on to step number 4 by solving for the remaining variable x. To solve for x, we get rid of the 2 by dividing both sides by 2. We get 2x divided by 2 equals 4 divided by 2. Simplifying the left-hand side, 2x divided by 2 is x, and on the right-hand side, 4 divided by 2 is 2. The result is x equals 2. Next, we move on to step 5, where we substitute our value for x, which is 2, into any one of the equations. I'm going to substitute our x value into the first equation, x plus y equals 3. We get 2 plus y equals 3. Solving for y, we subtract 2 from both sides of the equation. Simplifying the left-hand side, 2 minus 2 cancels out, and we bring down the y. On the right-hand side, 3 minus 2 is 1. The result is y equals 1. Our last step is writing our final answer as an ordered pair, so I have parentheses, 2, 1, close parentheses. If you ever want to verify that your solution is correct, you can always check them by plugging them back into the original equations. Moving on to part B, we have the system 2x plus 3y equals 17 and 5x plus 7y equals 29. You can see that both equations are already in standard form. The next step is to pick a variable to eliminate. We could either eliminate the x or the y variable. I'm going to choose to eliminate the x variable. Notice here the coefficient in front of the x variables are 2 and 5. What you want to do is find the least common multiple between 2 and 5. It's the same thing as finding the LCD, except you're not working with a fraction. The least common multiple, or LCM, between 2 and 5 is 10, so we need to change the 2x in the top equation to 10x. To do this, we multiply all of the terms in the top equation by 5. We get 5 times 2x plus 5 times 3y equals 5 times 17. Next, we need to change the 5x on the bottom equation into negative 10x. To do this, we multiply all of the terms by negative 2. We get negative 2 times 5x minus 2 times 7y equals negative 2 times 29. After doing the multiplication for the top equation, the result is 10x plus 15y equals 85. And then after doing the multiplication for the bottom equation, the result is negative 10x minus 14y equals negative 58. The next step is eliminating the x variable by adding together both equations. Simplifying the left-hand side, the 10x and the minus 10x cancel out. The 15y minus 14y gives us 1y. On the right-hand side, 85 minus 58 is 27. The result is y equals 27. From here, I chose to substitute my value for y into the top equation, 2x plus 3y equals 17. We get 2x plus 3 times 27 equals 17. Simplifying this equation, we get 2x plus 81 equals 17. Next, we solve for x by getting rid of the 81. We just subtract 81 from both sides of the equation. Simplifying the left-hand side, 81 minus 81 cancels out, and then we bring down the 2x. On the right-hand side, 17 minus 81 is negative 64. Next, we need to get rid of the 2 by dividing both sides by 2. We get 2x divided by 2 equals negative 64 divided by 2. Simplifying the left-hand side, 2x divided by 2 is x, and on the right-hand side, negative 64 divided by 2 is negative 32. The result is x equals negative 32. The final step is writing our answer as an ordered pair. I have parentheses, negative 32, comma 27, close parentheses. Next, we have a practice problem for you to try. Solve the system using elimination. For part A, we have the system of equations x plus y equals 5 and x minus y equals 3. For part B, we have the system of equations 5x plus 4y equals 22 and negative 3x plus 8y equals 18. Alright, so go ahead and pause the video, take your time working out these problems, and then check back with the video to see the solutions. Alright, so let's get started with part A. You can see that the equations are already in standard form. Also, we have that the y variables are already opposites. So we could go ahead and do the elimination. So we add the two equations together. On the left-hand side, x plus x is 2x, plus y minus y cancels out, and on the right-hand side, 5 plus 3 is 8. The result is 2x equals 8. From here, we could get rid of the 2 by dividing both sides by 2. We get 2x divided by 2 equals 8 divided by 2. Simplifying the left-hand side, 2x divided by 2 is x. On the right-hand side, 8 divided by 2 is 4. The result is x equals 4. The next step is taking our value for x and substituting it into either one of the original equations. I chose to substitute my value of x into the first equation, x plus y equals 5. We get 4 plus y equals 5. From here, we solve for y by subtracting 4 from both sides of the equation. Simplifying the left-hand side, 4 minus 4 cancels out, and then we bring down the y. On the right-hand side, 5 minus 4 is 1. The result is y equals 1. We write our final answer as an ordered pair. I have parentheses, 4 comma 1, close parentheses. Moving on to part B, you can see that both equations are written in standard form, and the easiest variable to eliminate would be the y. We have 8 and 4 as the coefficients of the y variable. The LCM, or least common multiple, between 8 and 4 is 8, so we only need to change the 4y in the top equation to negative 8y. To do this, we just multiply the top equation by negative 2. We get negative 2 times 5x minus 2 times 4y equals negative 2 times 22. The result after doing the multiplication is negative 10x minus 8y equals negative 44. From here, we could go ahead and do the elimination by adding together the two equations. Simplifying the left-hand side, I have negative 10x minus 3x is negative 13x. Minus 8y and the plus 8y will cancel out. On the right-hand side, minus 44 and 18 gives us negative 26. The result is negative 13x equals negative 26. From here, we get rid of the negative 13 by dividing both sides by negative 13. We get negative 13x divided by negative 13 equals negative 26 divided by negative 13. Simplifying the left-hand side, negative 13x divided by negative 13 is x. Simplifying the right-hand side, negative 26 divided by negative 13 is 2. The result is x equals 2. Next, we could substitute our value for x into either one of the original equations. I chose to substitute my value of x into the second equation, negative 3x plus 8y equals 18. Doing the substitution, we get negative 3 times 2 plus 8y equals 18. Simplifying this equation, we get negative 6 plus 8y equals 18. From here, we solve for y by getting rid of the minus 6. We just add 6 to both sides of the equation. Simplifying the left-hand side, negative 6 plus 6 cancels out, and we bring down the 8y. On the right-hand side, 18 plus 6 is 24. The result is 8y equals 24. From here, we get rid of the 8 by dividing both sides by 8. We get 8y divided by 8 equals 24 divided by 8. Simplifying the left-hand side, 8y divided by 8 is y, and on the right-hand side, 24 divided by 8 is 3. The result is y equals 3. Our final answer, written as an ordered pair, is parentheses 2, 3, close parentheses. In example number 6, solve the systems of equations. For part A, we have the system of equations x over 3 plus 2y equals negative 1 and x plus 6y equals 2. We can see that both equations are written in standard form. We just need to choose to eliminate either the x or the y variables. In this case, I'm going to choose to eliminate the y variables. The coefficients in front of the y variables is 2 and 6. The LCM, or least common multiple, between 2 and 6 is 6. So all I need to do here is change the 2y in the top equation to negative 6y. To do this, we multiply the top equation by negative 3. So we get negative 3 times x over 3 minus 3 times 2y equals negative 3 times negative 1. After doing the multiplication, the result is negative x minus 6y equals 3. From here, we could go ahead and do the elimination by adding together the two equations. Simplifying the left-hand side, x minus x cancels out, 6y minus 6y cancels out as well, so we get 0. On the right-hand side, 2 plus 3 is 5, so the result is 0 equals 5. However, 0 does not equal 5, so this is false. This means our system of equations has no solutions, so I wrote a circle with a line going through it. If you wanted to, you could also write a set of curly brackets with nothing inside of it. Moving on to part B, we have the system of equations 4x minus 7y equals 10, and we have negative 8x plus 14y equals negative 20. We could see that both equations are written in standard form, so we just need to choose to eliminate either the x variable or the y variable. In this case, it won't really make a difference. However, I'm going to choose to eliminate the x variable. So if we look at the coefficients, we have negative 8 and we have 4. So the LCM, or least common multiple, between 8 and 4 is 8. So we only need to change the top equation's 4x into positive 8x. To do this, we multiply all of the terms in the top equation by positive 2. We get 2 times 4x minus 2 times 7y equals 2 times 10. After doing the multiplication, the result is 8x minus 14y equals 20. Next, we go ahead and do the elimination, so we add the two equations together. Simplifying the left-hand side, 8x minus 8x cancels out, minus 14 plus 14 cancels out, so we have 0. On the right-hand side, we have 20 minus 20 gives us 0. The result is 0 equals 0, which is a true statement. This means we have an infinite number of solutions for the system. So we have two different ways that we could write our final answer. we would use set notation. The first way you could write out your answer is curly bracket, parentheses, x comma y, close parentheses, a vertical line, which means such that 4x minus 7y equals 10, and then close curly bracket. The other way we could write our final answer is almost exactly the same. The only difference is we would use the other equation in our system. So I have curly brackets, parentheses, x comma y, close parentheses, a vertical line, negative 8x plus 14y equals negative 20, close curly bracket. This is the end of the video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.